So for those of you who missed the first few classes, I'm Dana Nucitelli. I got a background in physics and astrophysics from UC Berkeley and UC Davis. Then I became an environmental scientist. I got interested in climate change. I saw An Inconvenient Truth, which got me really interested in learning about climate science. Then after I learned about it for several years, I started writing about it for Skeptical Science, which we're going to talk about a little bit today and next week. And then I got hired on to write for The Guardian in their environmental blogging network, International Environmental Blogging Network. And I've been doing that for about 5 years. I've published a few peer-reviewed climate science papers in that time. And I published my book, Climatology versus Pseudoscience, which every week I encourage you guys to buy. I encourage you once again to buy my book. You can just Google it, Google my name, put my name into Amazon, and then purchase the book is the most important part. And then my Guardian blog is called Climate Consensus to 97%, which I write with my colleague John Abraham from Minnesota, climate scientist from Minnesota, so you should check that out if you want to keep up to date with the latest climate science and policy news. So this week we're talking about climate models, climate predictions, who's been right, who's been embarrassingly wrong, which is fun I think that's fun to look at. So we're going to start in the 1960s. 1967 is kind of when the first modern computerized climate model was put together by these two scientists, Manabe and Weatherald. So they were scientists at the Environmental Science Services Administration in the 60s and thereafter. And so they put together a model and they wanted to know, we talked about this last week, when we double the amount of carbon dioxide in the atmosphere, how much global warming does that cause? That's called the climate sensitivity. And so they put together this model and they simulated doubling of carbon dioxide, and according to their model, by itself, that doubling of carbon dioxide would cause 1.3 degrees Celsius of global warming. And then on top of that, there are these various feedbacks we talked about. When the planet warms, ice melts and it becomes less reflective, and so it absorbs more sunlight, and so that causes more warming. That's one feedback. Another feedback is that a warmer atmosphere holds more water vapor, and water vapor is a greenhouse gas, and so when you get more water vapor in the atmosphere, that increases the warming too, and so that's a feedback effect. And so when they put all these feedback effects, or when their model simulated all these feedback effects, they found an additional 1.1 degrees Celsius of warming from a doubling of carbon dioxide. So when they put it all together, their estimate from their model in 1967 was that we would have a total of 2.4 degrees Celsius global warming at the surface if we double the amount of carbon dioxide in the atmosphere. So again, that's pretty close to today's estimates from today's climate models. They put the range at about 2 to 4.5 degrees Celsius if we double the amount of carbon dioxide in the atmosphere. And the best estimate today is about 3 degrees Celsius, and so theirs was 2.4 degrees Celsius. So theirs was pretty close in the 1960s, already getting very close to how much warming we expect to see from a doubling of carbon dioxide from today's much more high-tech, comprehensive climate models.
Dana, who is they? I'm sorry.
Their names are, I don't want to pronounce this wrong, Syukuro Manabe and Richard Weatherald. So that's the climate sensitivity. So then, a couple years later, 1971, I'm definitely going to pronounce this wrong, Ichtiakwe Rasul and Stephen Schneider, they did another study, and in their case, they wanted to look at, so at the time, starting in World War II, we started to burn a lot of coal because we were developing really fast, the economy was booming, we had a growing middle class, and so there was a lot of need for more energy, and so we started to put a lot of coal power plants into place, started burning a lot of coal. And so that was putting not just carbon dioxide into the atmosphere, but also we talked about in previous weeks is putting a lot of other pollution like sulfur dioxide in the atmosphere. And so in the 1970s, up from about the 40s and 50s to the 70s, the amount of sulfur dioxide in the atmosphere was increasing really fast. And so Rasul and Schneider, they wanted to know if that increase kept on going, if it kept on accelerating upward, the amount of sulfur dioxide in the atmosphere, they wanted to know, because that causes cooling, because it blocks sunlight, they wanted to know if that keeps accelerating, how much cooling is it going to cause. And so in their model, they had another pretty rudimentary early climate model, but they looked at a scenario in which we quadruple the amount of sulfur dioxide in the atmosphere because it was accelerating really fast. They say if it keeps accelerating, at some point the amount will quadruple. What will the effect on the climate be from that? And so they put that into their scenario. They put in, if we increase the sulfur dioxide by 4 times, their model said that the global surface temperature would cool by 3.5 degrees Celsius. And that's a really big cooling. We talked last week, the difference between the temperature now and the last ice age is about 4 to 5 degrees Celsius. So basically, if we were to quadruple the amount of sulfur dioxide in the atmosphere, that would cause enough cooling to basically trigger another ice age. So that's, a big deal. Obviously, if we're going to trigger another ice age, that's something to really worry about. And so this study made some big headlines. Newsweek and Time Magazine in particular had really big stories that were kind of sensationalist, kind of saying like, oh, a new ice age is coming. So that was not very good reporting because it's one study, it's looking at one scenario in which we quadruple the amount of pollution in the atmosphere. So it wasn't very good reporting. It was kind of like alarmist, sensationalist, like, uh-oh, ice age is coming, watch out. So the key point here is that that scenario didn't happen. The amount of sulfur dioxide in the atmosphere didn't quadruple. In fact, basically the opposite happened, and we'll talk about that in a minute. But first, the key point is that when we burn fossil fuels, it releases a bunch of different pollutants, especially if you're burning coal. You got carbon dioxide, you got sulfur dioxide, but also it's got metals like mercury and things like that. So burning fossil fuel has a lot of different adverse impacts to the environment and to public health. So we know that the carbon dioxide has a warming effect, we know that the sulfur dioxide has a cooling effect, and those kind of offset each other if you're not cleaning up either of them. And so, as I mentioned, between the 40s and the 70s, they were both increasing. They were roughly canceling each other out at the time because there was a lot of sulfur pollution, there was a lot of carbon dioxide pollution. And so basically the scientists in the 70s, they didn't know which effect was going to win out because they didn't know how our human behavior was going to change in the coming decades. So that's what this particular study was saying. If the sulfur dioxide wins out and its cooling effect wins out, what effect is that going to have? But, as I mentioned, that's not what happened. In 1970, Congress actually updated the Clean Air Act, and basically they said we need to do something about all this air pollution. The main reason was that at the time we had this big problem with acid rain, you guys might remember. That was a big deal in the 1970s because all the sulfur dioxide pollution, not only does it block sunlight, it also causes acid rain. Acid rain has all kinds of negative impacts on all kinds of environmental factors, but especially plant life. And so basically we decided we need to do something about this. We started to regulate sulfur dioxide emissions. Now we put scrubbers on coal power plants that kind of clean up the sulfur dioxide before it goes into the atmosphere. And so I've got a chart here that you can't see, but you'll be able to see the slides. So basically what it shows is that sulfur dioxide emissions go skyrocketing from the 1940s to 1970s, and then they kind of peak and they flatten out and they go down a little bit. And so 1971, when this paper was published, was kind of the peak, the very highest point where sulfur dioxide emissions were accelerating, and then thereafter they started to go down. And so the point is that they're looking at a scenario where from 1971, the amount of sulfur dioxide in the atmosphere quadruples. What actually happened is the amount of sulfur dioxide in the atmosphere decreased. And so basically their scenario that they were considering didn't happen. But that hasn't stopped people from kind of misconstruing their study. And so climates, contrarians, deniers, whatever you want to call them, recently they actually created a fake Time magazine cover that I've got on this slide. And so basically in 2007, Time magazine ran like a special edition called the Global Warming Survival Guide. And there basically Time had this big story about what we're going to do about global warming, what the problem is, what the solutions are, and things like that. And so somebody took that and decided to Photoshop it. And they Photoshopped it, instead of saying the Global Warming Survival Guide, now it says how to survive the coming ice age. And so like in the top, they did a really good job actually of this. In the top corner in the real-time cover, there's like a little Sopranos blurb, and they changed it to make it a little MASH blurb because in the 1970s MASH was like the key TV show. And so basically they photoshopped and they just really edited out these little bits to make it look like it was a 1970s Time magazine cover saying that a new ice age was going to come. Whereas in reality it was a 2007 Time magazine saying global warming is a problem, we need to do something about it. And so The left one is the fake one, the right one is the real one, which you'll be able to see in the video. So this has been a really popular and kind of damaging myth. The idea is that climate scientists were totally wrong in the 1970s, so why should we trust them now? And so the issue is they weren't wrong in the 1970s. And so this is a key point. It's the difference between what a projection is and what a prediction is. And so, for example, if I make a prediction, I'm going to lose 10 pounds in 1 month. Then I'm saying 1 month from now, I will be 10 pounds lighter. But I can also make a projection. And I can say, if over the next month I eat 50% fewer calories, then I will lose 10 pounds in 1 month. So I'm saying, under scenario X, the outcome will be Y. That's a projection. That's different from a prediction where I'm saying just in a month I'll lose 10 pounds. And so if over the next month I don't change my diet, I still eat a bunch of like cake and popcorn and ice cream and stuff, and I don't lose 10 pounds, that doesn't mean my projection was wrong. It means I didn't fulfill the scenario in my projection. So it could have still been true if I had stopped eating all that cake and ice cream and stuff and gone on a diet, then I might have still lost 10 pounds, but the fact that I didn't do the diet and didn't lose 10 pounds, that doesn't mean that the diet doesn't work. And so that's basically what this myth is. The myth is saying, climate scientists in the 1970s said there was going to be an ice age. There wasn't an ice age, therefore climate scientists are stupid. And that's not true. Climate scientists are actually very smart. So I think that's really a key thing to get out of this class, is that climate scientists are smart people. Like, we should bear that in mind. They know what they're doing. This is their job. And they are smart people. So basically the trick is to take this projection, pretend that it was a prediction, and to say that they're wrong. And that's just not the case. And so that's a very popular myth. As it happens, next week we're going to go through, the whole class is going to be devoted to climate myths like this, and so that's kind of a fun one that I like to do. I love doing climate myths, so make sure you come back next week for climate myths. Okay. So then, the next year, in 1972, we had another scientist named John Stanley Sawyer, J.S. Sawyer. So he was a British meteorologist, born in 1916. And in 1972, he published this really important paper about climate change, modeling how much global warming we're going to see. So the first thing he did, he predicted how much carbon dioxide would increase by the year 2000, and then he predicted how much global warming that would cause by the year 2000. So in his paper, there's this quote: "The increase of 25% carbon dioxide expected by the end of the century corresponds to an increase of 0.6 degrees Celsius in the world temperature. That's an amount somewhat greater than the climatic variation it reached in centuries." And this concept of climatic variation is an important one that we're going to come back to several times in this class. Basically, we talked last week about these natural cycles. There's ocean cycles like El Nino, and there's these orbital cycles. And basically, over the short term, there's kind of these wobbles in the temperature as these cycles happen. And these are called natural variability, natural variation. And so these wobbles, they're usually no more than 0.2 or 0.3 degrees Celsius, kind of up and down. So that's important to keep in mind. So he's saying if we get between 1972 and 2000, 0.6 degrees Celsius, that's more than that 0.3 degrees Celsius natural variation. And so at that point, we'll be able to say, okay, something more than natural variability is happening. It's, we're obviously at this point, we're going to be able to say we can see human-caused global warming by the year 2000 if we keep putting this carbon dioxide into the atmosphere. So he said we expect to see 25% carbon dioxide increase by the year 2000. What actually happened is we saw a 32% increase in carbon dioxide. So he was very close in his kind of anticipation of how much fossil fuels we would keep burning. And then he predicted a 0.6 degrees Celsius warming. What we actually saw was a 0.7 degrees Celsius warming. So he was actually very close, both in anticipating carbon dioxide increase and in anticipating how much warming that would cause. So his paper talked about other really important aspects of climate change. He talked about the fact that it takes about 100 years from when the carbon dioxide doubles or from when the carbon dioxide increases until the planet reaches a new energy balance. So we talked about this in the second week, where basically the Earth, you have incoming energy and you have outgoing energy. And if those aren't the same, then you have a global energy imbalance. And so that global energy imbalance is what causes long-term temperature changes. And so when a temperature change reaches a certain amount, then the planet's energy balance is back. It's in balance again, and that's when the warming stops. And so that takes actually 100 years. That's mostly because the Earth is mostly ocean, and it takes a lot of time to heat water. And so we call this the thermal equilibrium of the oceans. Just it takes a while for that to happen. And so his paper said that would take about 100 years, which is still about what climate models today say it takes. So that was impressive. He talked about warming feedbacks from melting ice, which we talked about. The melting ice decreases the Earth's reflectivity and makes it warm more. He talked about cooling from cloud cover because clouds in the atmosphere, their clouds are white, and so they reflect sunlight, and because they're reflecting sunlight, they're causing a cooling effect. And he talked about the increase in water vapor in the atmosphere causing more warming, being a feedback effect. So this was 1972. His climate model was already grasping all these important aspects of how the climate works. So then in 1975, we had Wally Broecker. He was an American climate scientist. And in 75, he published this really important paper. The title of it was Climatic Change, Are We on the Brink of a Pronounced Global Warming? And so that paper is often credited with being like one of the first uses of the term global warming and kind of popularized the use of the term global warming. That's because it was just a very influential paper. And so what Broecker did is that he wanted to model two effects. He wanted to model both natural cycles, and he also wanted to model increasing carbon dioxide. And so he wanted to put those two things into his model and figure out, first he wanted to match the warming that had happened to date as of 1975, and then he wanted to project how much warming would continue to happen. So one of the challenges he faced is that in 1975 we didn't have a very accurate data set measuring average global surface temperatures. So we've got thousands of temperature stations all over the planet, but as of 1975, nobody kind of put those together into a comprehensive measurement of average global surface temperature, and so he just kind of had to go with the best data that he had, and so his available data wasn't as accurate as later available temperature measurements, so that made it a little bit of a challenge for him to model it accurately. And his model is also very simple. As I said, he's only measuring natural cycles, his estimate of natural cycles in carbon dioxide. So, for example, he's not including solar effects or volcanic effects. He's just kind of hoping those get captured in his natural cycle. So on this slide, we've got a comparison of the observed temperatures and Wallace Broecker's model predictions. And so basically, he had sort of a very sweeping curve because he's trying to include all these natural effects in his natural cycle. And so he kind of overestimated what the natural cycle was because he's including volcanoes and solar activity and things that aren't actually cyclical in his cycle. And so he overestimated a bit. So it's a very curvy curve. But it's actually pretty close to the observed temperature. So in this chart, the observations are the solid line and the prediction is in the dashed line. And so it's actually a pretty good match once you'll be able to see it. It is a pretty good match despite being a very simple climate model, despite only sort of modeling all these natural effects as a cycle the best you can, despite having not very good temperature data available at the time, he was still able to pretty accurately predict how much global warming would happen. It's important to bear in mind that as of the 1970s, he could have predicted anything. He could have predicted a drastic global cooling. He could have predicted no temperature change at all. He could have predicted slow global warming. So there's like an infinite number of predictions he could have made. And the one he made was pretty close to what actually happened. So that's pretty impressive. So fast forward a few years, 1981. That's the year I was born. That was a great year. James Hansen. We talked about him a little bit last week when we talked about the 1979 Charney Report, which was this big, important report that a bunch of top scientists made talking about climate change. And so at the time, James Hansen, he was sort of just a budding scientist. It was very early in his career. He had done his PhD modeling the greenhouse effect on Venus, and they brought him on to model the greenhouse effect on Earth. So that was 1979. He got hired on at the NASA Goddard Institute for Space Studies, and so he was working there in 1981, and he was working on his climate model. And so he, in 1981, published this really important paper where he was modeling, again, if we increase carbon dioxide in the atmosphere, how much global warming will that cause? And he was trying to incorporate all these different factors on Earth, the oceans, the atmosphere, everything into his climate model to see how much global warming we can expect to happen. And also, I should mention, in the 1980s, James Hansen's group was the first one to really create a comprehensive database, bringing together all these temperature data from all around the planet and these thousands of temperature stations, bringing it all together and creating one overall database measuring the global average surface temperature. And so at this point, we finally had like a really good estimate of how much global temperatures had changed over the previous 100 years or so. So, in his 1981 paper, he's got a good quote. It says, "The global temperature rose by 0.2 degrees Celsius between the middle 1960s and 1980, yielding a warming of 0.4 degrees Celsius in the past century." So basically, from about 1900 to 1960, we had about 0.2 degrees Celsius warming. From 1960 to 1980, we had another 0.2 degrees Celsius warming. That's according to their new data set. This temperature increase is consistent with the calculated greenhouse effect due to the measured increases in atmospheric carbon dioxide. So he's saying at this point, if warming were caused by carbon dioxide, we would expect to see about as much as their database had measured at that point. Goes on to say, "It is shown that the anthropogenic carbon dioxide warming should emerge from the noise level of the natural climatic variability by the end of the century," which you can remember is pretty much the same thing that Sawyer had said in 1972. By the end of the century, we expect to be able to see the human effect going beyond that natural variability. So at that point, we had seen 0.4 degrees Celsius. That could still pretty much be natural variability causing that warming. And there's a high probability of warming in the 1980s. So 1981, he's saying, over the next decade, because carbon dioxide is going to keep increasing in the atmosphere, we're probably going to be able to see, we're probably expect to see additional warming in the 1980s, as long as there's no like big cooling effects like a big volcanic eruption, for example. So we probably will see warming in the 1980s to 1990. And by 2000, we can expect to be able to say that there is a human contribution to the warming by that point, because it should, by 2000, it should be beyond that range of natural variability of about 0.3 degrees Celsius. So, in that 1981 study, they ran their global climate model. They used combinations of the three main effects on global temperature, which is carbon dioxide and the sun, and particulates released from volcanic eruptions. So they put together their best estimate of what had happened up till 1980, and then they projected forward what would happen under various carbon dioxide emission scenarios. Obviously, we can't predict what's going to happen with the sun, or we can't predict what's going to happen with volcanoes. So he threw like a couple of random volcanic eruptions in there just to see what would happen. So he had two different greenhouse gas emission scenarios. He had like a fast one if we burn lots of fossil fuels, and then a slow one if we kind of slowed down our fossil fuel burning. As it happened, we ended up being kind of right between those two scenarios. We kind of had like a moderate fossil fuel burning after 1981. And so in his fast scenario, his model projected about 0.17 degrees Celsius warming per decade. And in the slow scenario, it projected 0.13 degrees Celsius warming per decade. So between those two is what happened. He would have expected to see about 0.15 degrees Celsius per decade if he had known exactly how much fossil fuels we would end up burning. So the actual warming that we saw starting in 1980 until recent years has been about 0.18 degrees Celsius. So he expected about 0.15 degrees Celsius per decade. We saw about 0.18 degrees Celsius per decade. So it was pretty darn close to what his model expected to see. It was about 20% faster, but very, very close to what his 1981 model projected the warming would be. So on this slide you can see the comparison between the observations and the two scenarios. The solid line is the observations, the wide dashed line is the slow scenario, the narrow dashed line is the fast scenario, and then it kind of went right between those two. And so it just shows how accurate his model was. Again, bearing in mind that he could have predicted anything, cooling, warming, no change, and the prediction of his model, or the projection of his model, was very close to being spot on to what actually happened. So then fast forward to 1988, Hansen published another paper. Basically, at that point it had been 7 years. His model had become a little more comprehensive, and so he wanted to do it once again, another projection. In this case, he looked at 3 different scenarios, called them A, B, and C. And so in scenario A, he looked at basically if we started to burn lots and lots more fossil fuels, an acceleration of fossil fuel burning, kind of a worst case scenario. If we start to just like burn tons of coal, tons of oil, what would happen in that scenario? His scenario B was like a steady carbon pollution scenario, so kind of like a business as usual sort of scenario. And then his scenario C envisioned that in 2000 we enacted some kind of global climate agreements in which we started to reduce our greenhouse gas emissions. That would have been nice if that had happened. Unfortunately, it didn't, but that's his scenario C. So what actually happened was actually between his scenario B and scenario C. The reason being that we talked, I think it was last week, we talked about the depletion of the ozone layer, and that's being caused by chlorofluorocarbons, CFCs. And we were worried about that in the 1980s, and so in the late 1980s there was this international agreement called the Montreal Protocol that phased out the use of these CFCs. It turns out CFCs are also pretty powerful greenhouse gases, and so when we phased those out to slow down the depletion of the ozone layer, it actually also slowed down global warming a little bit. And so even though we didn't do anything about carbon dioxide, so the carbon dioxide stayed on kind of the business as usual scenario, the CFCs declined, and so that puts the actual greenhouse gas scenario, if we put it all together, between Hansen's sort of business as usual scenario B and his basically his optimistic scenario C. It was kind of in between those two. So on this chart, there's the comparison of his model projections, which is the dashed line, and the solid line is the observational data. You can see there was actually a little bit more warming than Hansen's model projected. He predicted about I believe it was about 0.25 to 0.3 degrees Celsius per decade. It ended up being about 0.2 degrees Celsius per decade. And so he had a little bit more, there was a little bit less warming than his model anticipated. Just the way it was built, the climate sensitivity in his model was about 4.2 degrees Celsius warming in response to a double CO2, which is within the range, but it's at the high end of what we expect from today's climate models, which is 2 to 4.5. So we expect most likely, based on today's climate models, 3 degrees Celsius warming in response to double CO2, and Hansen's model had a 4.2 degrees Celsius sensitivity. So it was a little more sensitive than we think is accurate today, and so it showed a little bit more warming than we expect to see, and so it overestimated global warming a little bit, but it was still pretty close. And so 10 years after that, there was a congressional hearing, 1997-1998. And this was leading up to the Kyoto Protocol, which we talked about last week. There was another international talk. They were trying to agree to reduce greenhouse gas emissions. A bunch of countries did agree. The Clinton administration signed it, but the Senate refused to ratify it. So this is while they were doing the negotiations. There was this big congressional hearing. And they brought in this guy, the Republicans brought in this guy named Patrick Michaels. Patrick Michaels, he has spent his career working for the Cato Institute, which is this conservative think tank, gets a lot of fossil fuel funding. Let's just say he's not an unbiased source of information about climate change. He actually, at one point, he was interviewed and he was asked how much of his funding comes from the fossil fuel industry, and he estimated 40%, which means it's probably a lot more than 40%, but he was willing to admit that 40% of his salary was paid by the fossil fuel industry. So he's invited to testify before Congress in the 1997-1998 hearing. And one of the things he talked about was James Hansen's 1988 predictions, or projections, that paper. And so on this chart, on this slide, I've got the chart straight out of Hansen's paper where it shows scenario A, scenario B below it, scenario C below that. And what Patrick Michaels did is he brought a chart into Congress and showed it to Congress. And his chart showed scenario A, and that was all it showed. And it showed in scenario A between 1988 and 1998 or 1997, Hansen's model, scenario A, expected 0.45 degrees Celsius. There was much less warming than that, and therefore Hansen's model was alarmist, it was inaccurate, and you can just throw it out, ignore everything that Hansen said, he's not credible, and we can just forget about global warming is clearly not a problem because James Hansen says it's a problem, and James Hansen was wrong. And that was his testimony, which I would say is basically perjury. So what actually happened was that, as we talked about, the greenhouse gas emissions between 1988 and 1997 were between scenarios B and C. And Patrick Michaels took the chart and he deleted scenarios B and C and just showed scenario A, which was the least representative of what actually happened. And this gets back to our projections versus predictions discussion. So the projections that the scenarios that were most accurate were B and C, and James Hansen's model very accurately predicted how much warming ensued after that. Slightly over-predicted it, but not by very much. So if Patrick Michaels had showed all three scenarios, or just B and C, it would have looked like Hansen was pretty good, because Hansen's model was pretty good. Instead, he just showed scenario A, which was not representative of what actually happened, and just totally misrepresented Hansen's model and its accuracy. So that's the kind of misrepresentation that's very common when climate contrarians or climate deniers are trying to discredit climate models and climate scientists and mainstream predictions. So I think that's important to bear in mind. So then, going back a little bit, back to the year after Hansen's 1988 paper, in 1989, there's this guy, Richard Lindzen. So he is an American atmospheric physicist. He was at MIT. He retired a few years ago. In the 1970s, he actually did some pretty good, important atmospheric research. And so he got on MIT, and he got kind of a good reputation as being a good scientist. And then after that, he became sort of the most prominent climate skeptic, contrarian, whatever you want to call him. I've actually written about him quite a lot. If you go to like Skeptical Science, there's like actually a little button to a series that I wrote called Lindzen Illusions, because I've looked at pretty much all the things that he said, all the predictions that he's made, and I've described him as a climate scientist who's been the wrongest the longest, because he's been around for a long time, and pretty much everything he said has turned out to be wrong. And it's kind of a bee in my bonnet that he, nevertheless, his credibility is like, it's like stainless steel. It's like you can't touch his credibility. Like, it doesn't matter how wrong he's been, how often, he nevertheless, gets brought before Congress to testify, or used to. All the time be brought before Congress to testify. He would be in the media articles all the time. If a newspaper wanted to have a balanced article, they would talk a balanced quotes article. They would talk to a mainstream climate scientist, and they would say, "We want to get the other side. Let's talk to Richard Lindzen." And Lindzen would then come and say a bunch of incorrect stuff. And so he is a guy who's really aggravated me for a long time. And in 1989, he gave, it's called a tech talk at MIT, where he talked about climate change and global warming. And he has never made a concrete quantitative prediction of how much global warming would happen. But in that tech talk, he made some comments that allow us to kind of reconstruct what his prediction might have looked like. And so in that tech talk, he said, one of the things he said was, "I personally feel that the likelihood over the next century of greenhouse warming reaching magnitudes comparable to natural variability seems small." And so we talked about natural variability is about 0.2 to 0.3 degrees Celsius. So he's saying between the late 1900s and the late 2000s, he doesn't expect to see more than 0.2 or 0.3 degrees Celsius warming. He also made comments at that time. James Hansen's NASA reconstruction of global temperatures was already in place, and basically he said he didn't trust it. He thought that it was overestimating the warming that we had already seen. And so, one, he's saying, I don't think there's been very much global warming to date, and he's saying, I don't think there will be very much global warming in the future. And so based on his comments, I put together this chart, which it's not his, he didn't draw this curve, but based on his comments saying that we hadn't seen much global warming to date, and we would only see a little bit of global warming in the future, I put together this chart. The dotted line in the bottom is sort of my reconstruction of what his prediction would have looked like based on those comments, and then the solid line is the observations. And basically on the bottom with his dotted line is pretty flat. It only shows a little bit of warming, and then we've actually seen a whole bunch of warming. And so there's this big divergence between his prediction of almost no warming and the actual observations of lots of global warming. So basically, everything he said in that tech talk in 1989 was wrong. That's my conclusion from that. And like I said, it never seemed to hurt his credibility. He was on CNN and all these different news shows, and he was in the media, newspapers all the time, and he talked in all kinds of conferences and things like that, especially fossil fuel funded conferences. When he retired a few years ago, and now he works for the Cato Institute, which, as I said, is the fossil fuel funded think tank. So, kind of reminds me of members of Congress. When they retire, they always seem to go and become lobbyists. That's basically how I view Lindzen. He kind of spent his career sowing doubt about climate change. He kind of spent his credibility capital He built up his credibility in the 1970s and kind of spent that casting doubt on climate change, climate science, and then he retired and he started to get paid by the fossil fuel industry for it. So let's see. This is probably a good place to take a break before we're going to talk about the IPCC reports next. So let's take a little break and come back at about 5 minutes to 11.